Hi everyone, today I'm going to show you a tutorial on the Johnson rules in which it applied to two or more machines. For this case we have two work center in which we have work center A and B, and we have 5 jobs that need to be completed. And first step is we need to rearrange the sequence, and then we will have the in and out table to calculate the idle time for each workstation and also job waiting time. And at the end, we need to draw a Gantt chart. Okay, first, we need to use Johnson rule to do the optimal sequence. So since we have 5 jobs, so we need 5 slots here, and then we start with the smallest or the smallest time here, in which this is 1.5, and since it's in the workstation B, so we will start at the end. Okay, so they're going to be B, and then we cross out B, and then the next one is here 2. So since 2 at workstation B again, so we need to go to start from the back. So E is going to be here, and then we cross out E, and then the next one is going to be 2.2 C, and since C is in the workstation A, the smallest time, so it's going to start from the front. Okay, so C is going to be here, and then we cross out C, and then the next one is going to be 2.5 since it's work center A, so A gonna go from the front. Okay, so we have A here, and automatically we know that D will fit in the middle. So our optimal sequence is C, A, D, E, B. So next, what we have to do is we have to make the in and out table. Okay, these are the optimal sequence using the Johnson rules that we have done earlier. So we start with 0. Okay, so we read from the table here. Since start with C with in work center A, we're going to start with work center A here first. Okay, so 0 going plus 2.2. We have 2.2, and we bring 2.2 here, and then A for our work center A, it's 2.5. Then we get 4.7. We bring 4.7 here, and then D is 5.8, so we plus 5.8, we get 10.5, we bring 10.5 here, and E is 4.5, we got 15, and we bring 15 here, and B is for work center A is 3.8, so we get 18.8 here. And then now, we can start with the work center B. Okay, for work center B, what this thing tell you that after finish job C, they will go into workstation B. So you're going to start at 2.2 here. Okay, so 2.2 plus for C work center B is 3. We get 5.2, and then we bring 5.2 here. Okay, we check first. So this A will be done at 4.7 hours. So then we can start 5.2 here, okay, for the workstation B. And A for workstation B is 4.2, we got 9.4. And then again, we check first. Okay, be careful here, even though we have finished early, but job D only will come into workstation B on the 10.5. So what workstation B will do? So workstation B just idle, doing nothing here. Okay, so the machine or the workstation just idle here until workstation A finish with the job D at 10.5. Then only the work center B will start working again. Okay, so again we check here. D is 4 plus 4, we got 40.5, and then again the workstation B finished at 40.5, but job E is still working in the workstation A, so work center B will wait. Okay, will be idle, not doing anything until the 15. hours, okay? At the 15 hours, then the job E come in into workstation B, and then the processing time takes about E is 2 here, plus 2 is got 17, and even though it's finished at 17, again, B only come in into workstation B at 18.8, so workstation B again, idle time, waiting for job B to come in, so only start at 18.8, and then B, workstation B is 1.5, so we get 20.3. Okay, so for workstation A, we have no problem in getting in and out, but be careful when you start doing the workstation B, in which sometimes for this case, even though it's finished earlier, but it cannot work until job D completed at 10.5. So the work center B have to be idle, okay, not doing anything. Okay, now what's next? So these are the table that we completed. Remember, we get 20.3. This is very important information here, in which it tells us the total processing time for all the job here will be completed after 20.3 hours. Okay, so it means that the work center A and B will stop working at 20.3 and all the job will be finished by then. Okay, next. The question asks us, calculate the idle time of each workstation. Now we have workstation A and B. Okay, we start with workstation A. A only can be idle, means that A don't do anything or it stop working at the end. Okay, it stops at 18.8, but the whole job will be finished only at 20.3. So they have idle time for machine for workstation A. Okay, for this scenario, so we have 20.3 minus by 18.8. It means that 1.5 hours idle machine time for workstation A. So workstation A has a earlier rest time, okay, because it's done working with the job B. So waiting for machine B, workstation B to stop. So it has 1.5 idle time. Okay, that's quite easy for workstation A, and workstation B is a bit tricky here. What you have to do, the first one is confirm idle time for workstation B, because the first job C is in the workstation A. So workstation B have to wait. Wait how long? So it's going to be 2.2 hours here. And then be careful, we check. Is there any idle time here? No. When it's finished at 5.2, then another job come in. Okay. For this case, we just seen this earlier. It finished early, but it cannot do anything because job D is still in the workstation A. So they have idle time here. Okay. And then here also, remember, we discovered that it finishes 14.5, but job E only comes into workstation B at the 15 hours. So we have like 0.5 here. And yeah, for this one also, it finished at 17, but the job B only comes in at 18.8. So we have 1.8 here. So for machine 2, the idle time is, we plus the 2.2 from the earlier. And then remember, in between job here, that they have the machine workstation B have some idle time here, 1.1 plus 0.5 and plus 0.8, so we get 5.6. Okay, what does it mean that workstation A only idle for 1.5 hours, but workstation B have 5.6 hours idle time? Okay, so for the total machine idle time, for this case, A and B, we get 7.1 hours. Okay, next, the question asks us to determine the job waiting time. So in between the 5 jobs, what are the waiting time? So this is quite easy to determine, in which we just compare the time that it gets into work center B. So for first case, there's no waiting here for job C, and for this one, yeah, there's a waiting time. in which that job A finished at 4.7, but it couldn't go in to workstation B because it's still working with the job C. So it wait about 0.5, and here no waiting time. Good, here no waiting time, and here also no waiting time. So the job waiting time here is only 0.5. Okay, now the next step is going to draw the Gantt chart. Remember, this is our in and out table. Okay, for the Gantt chart, we need to draw the first workstation, in which workstation A. Okay, so remember, we start with 0 and then follow 0.2 here, C, and then A, 2.2 to 4.7, and you do all the sequence, okay, until B, and then remember that even though here is finished at 18.8, we need to draw until 20.3 here. Okay, I'll show you here that. Alright, then what you have to do is you will start with work center B. Okay, and before that we check. Okay, yeah, there's a idle time here. Remember, when it's finished job B, workstation A can start resting. Okay, resting, and then because we're waiting for workstation B, so it has here idle time. And then for the workstation B, so remember, okay, we start here 0, so make sure it's still start here 0, but it only works at 2.2. So it has the idle time here, remember, yeah? And then 2.2, 5.2, and then for A, we have 5.2 to 9.4. And then remember, in between here, we have idle time, okay, the idle time for the work center B. So here 1. And then you start 10.5 to 40.5, and again we have one idle time here, okay, and then 15 to 17, and then again we have idle time here, okay, and then the end 18.8 to 20.3. Okay, so we check again. Yeah, we have one idle time here to match this one, and this one to match this one, this one to match this one, and this one to match this one, and this one to match this one. So it means that we have completed our Gantt chart for the Johnson roles. Alright, okay, thank you. Hope you understand, and we'll see you again. Bye.